Hi everyone and welcome back. In the first part of electricity, we discussed what is electricity. We try to define electricity and also the basic formula I is equal to Q by T and Q is equal to NE. In this part, we are discussing 5 numericals based on the formulas Q is equal to NE and I is equal to Q by T. If you watch this video completely, then you can solve any numericals in the same pattern. First question, 0.5 coulomb charge passes through a cross section of conductor in 5 seconds. So here 0.5 coulomb charge passing through a cross section in 5 seconds, right? So here you are given with charge that is represented by letter Q. So Q that is given by 0.5 coulomb. Unit is coulomb. Unit is too important. Okay, SI unit you must maintain always. Okay, next time. It is passing for the time that is 5 seconds. For 5 seconds, this is flowing through, the charge is flowing through the cross section. Okay, whenever you are solving a physics numerical, first you want to understand what all the given things. So these are the given things, given quantities. After that, we want to understand what we want to find, right? In this case, we want to find current. Okay, current we want to find. So we don't know what is current, right? This current I that we are going to calculate. So for that, we have the basic equation I is equal to Q by T. I is equal to Q by T. Now check for the values of Q and T, right? Q is given by 0.5 coulomb and time that is 5 seconds. Look here, coulomb is the standard SI unit and here second that is also SI unit, right? Now just we can substitute that 0.5 divided by 5 coulomb and here seconds. If we solve this, what you are going to get here, I that you are going to get 0.5 divided by 5 that is 0.1 and unit of current. Unit of current that is ampere. We are representing that one with the ampere and okay, let's put in a box. I is equal to 0.1 ampere. Now the second example, calculate the number of electrons constituting 1 coulomb of charge. This is an NCERT textbook question, right? Calculate the number of electrons constituting 1 coulomb of charge, which means for contributing 1 coulomb charge, how much electrons we want. So this is a question asking for number of electron, right? Here only one given quantity, that is charge that is represented by Q, that is 1 coulomb charge we want to make. For that, how much electron we want to find? We want to find what is N. Okay, so here Q and N. Q and N, for that we have a relation Q is equal to NE, our second formula. Then what is E? E is the charge of 1 electron, right? Charge of 1 electron. Charge of 1 electron 1.6 into 10 raised to minus 19 coulomb. Right. Now Q that is a charge, coulomb, electron that is also a charge, so its unit is coulomb, both are in SI unit. Now finding N, just substitute the values of Q and E here, right? N is equal to Q by E. So Q value that is 1 divided by 1.6 into 10 raised to minus 19. 1.6 into 10 raised to minus 19, right? Both are coulomb and downside also coulomb, right? Now coulomb that get cancelled. Let's divide 10 raised to minus 19. If we take into numerator, it's going to be 10 raised to plus 19, right? When we move exponents from numerator to denominator, then its sign will change. It is now it is 10 to the power 19. Now about division, 1 divided by 1.6. 1 divided by 1.6 that is 0.625. 0.625. What is the unit here? there is no unit because it is a count, right? Number of electron we are finding here. So we got the number of electron, that is 0.625 into 10 to the power 19. Don't think it is too small. Look, 10 to the power 19. How many zeros are there? 19 zeros are there. So such a big number it is. Okay. Third question. An electric iron draws a current of 0.5 ampere when voltage is 200 volt. So two quantities given here. I is equal to 0.5 ampere. That is the first one given. And voltage, that is not familiar for you now because it is in the coming session, right? So here voltage, we will represent that one with the letter V. Okay, voltage 200 volt. Calculate the amount of charge flowing through it in 1 hour. How much charge is flowing through the electric iron? That is the question. Let's calculate the charge here, right? Total charge Q is equal to I into T, right? Because I is equal to Q by T. T we are taking this side, then Q is equal to I into T. Just substitute the value 0.5 ampere, that is into time, that is 3600 seconds. Then if you multiply this 1800, unit of charge, that is coulomb. So here we got Q is equal to 1800. Fourth question. The filament of an electric lamp draws a current of 0.4 ampere which lights for 3 hours. By drawing a current, that is given by 0.4 ampere, okay, it's gonna light for 3 hours. Now remaining part of the question. Calculate the amount of the charge that flow through the circuit. So we want to find amount of charge that flows through the circuit. Amount of charge. What is that? Q. Total charge we want to calculate in this case. Okay. So amount of charge Q. So I and T both are given. So we have the formula I times of T. Before substitution, just check the units. Amperes 0.4 ampere, no problem, and time, that is 3 hours. Here the problem, this is not in SI, so let's convert it. Okay, 3 into, just multiply with 60 into 60. Now it is in seconds, right? Substitute here, that is 0.4 into 3 into 60 into 60. So final output 4320. This unit, that is coulomb, because charge unit. Okay, so charge, total charge, that is equal to 4320 coulomb. Now our last example. A conductor carries a current of 0.2 ampere. Find the amount of charge that will pass through the cross section of the conductor in 30 seconds. How much electron will flow in this time if the charge of one electron is 1.6 into 10 to the power minus 19 coulomb. Okay, question has two parts. First part, a conductor carries a current of 0.2 ampere. Find the amount of charge that will pass through the cross section of the conductor in 30 seconds. Okay, in 30 seconds, how much charge is going to flow there, right? So first one, current I is equal to 0.2 ampere, and second one, time, that is 30 seconds. Now charge Q, without any doubt, I times of T. SI unit, here also SI unit, so just substitute 0.2 into time, that is 30 seconds, right? So here this is in ampere and this is in seconds. If we multiply these two, okay, that is going to be 6 coulomb. Second part of the question, how much electron will flow in this time interval if the charge of one electron is 1.6 into 10 to the power minus 19. So they are asking for number of electron. So we have the equation Q is equal to Ne. So here Q is 6 coulomb, that is equal to number of electron we want to find. How much electron is going to flow, that is question, right, into charge of one electron, that is 1.6 into 10 to the power minus 19 coulomb. In this case that is given, otherwise you know the value of E, that is 1.6 into 10 to the power minus 19. Now calculate for N. 6 divided by 1.6 into 10 to the power minus 19. 6 divided by 1.6, that is equal to 3.75 into 10 to the power 19. 10 to the power 19, not minus 19 taking upside, right? So here no unit because it is a count. Okay, so in this question there were two parts. Okay, first one finding the value of Q, second one finding the number of electrons. So this is the last example. So I hope you understand. Meet you in another video. Till then, bye.